Hello YouTube! Today we're going to be doing something a little bit different. Here on screen I've got a circuit that I've just drawn out in LT Spice. It looks a little bit complicated at first, but don't worry, I'll break it down. You may be wondering about the title of the video. What's this supposed to be? Something about detecting the polarity of a magnet? How do you do that? Well, to begin, let's just take a look at the diagram. On the top left here, with the voltage and stuff, you can see something with the label Induced Voltage. This is just pretty much simulating or standing in for the inductor that I'll be using, which is literally just a coil of wire held together by tape in real life. Because, you know, LT Spice, strangely enough, doesn't really have a way to simulate waving a magnet over a coil of wire, so a voltage source controlled by a sine wave will do good enough for now. And then next to that, we just have a non-inverting amplifier, and using the values of R2 and R1, which are just resistors, we get some absolutely
massive gains
in voltage, because the output of both this sine wave controlled voltage source and the induced voltage created by the actual coil itself is pretty small. And then down here is just the output circuit. D2 and D1 will flash in a certain pattern depending on what the polarity of the magnet is. And to the right is just the power circuit. So without further ado, let's simulate the design. And we will want to probe the input, so right into the positive terminal of the amplifier here. And you can see that that's a pretty clean waveform. And now let's create a second plot. Hold on a moment, I always forget how to. Okay, add plot plane, and with the second plot plane, we will want to take a look at the output. And because this is just a basic non-inverting amplifier, oops, I did not mean to do that. You can see that it rails out at a certain positive voltage and a certain negative voltage, and this here should be enough to drive these LEDs once we're done. So now let's also take a look at the actual physical design. So down here is the actual circuit built out. I do also have it right here on I forget what it's called, Analog Discovery 2 Digital Waveforms, the software. And if I show you here, the supply is already turned on, and let's just take the north pole of this magnet and just wave in front, and you can see that the red LED flashes first and then the yellow LED. And it's just really quick. This all depends on the flux transition. So in short, the induced voltage is caused by the changing magnetic field or changing magnetic flux passing through the center of this coil of wire. So, oh, I bumped the tripod again. I always do that. So this is the north pole right now, but then if I flip it over, you can see that with the south pole, now the yellow LED will flash first. And so another thing that we can do is, going back to here, let's also turn on the waveform generator. And now, I might have done something wrong. I don't know. I might not have hooked up the probes correctly. Oh well. But anyway, yeah, the basic point is here, I can actually just have the oscilloscope running, and then this is the north pole, and you can see the blue trace is using a 2 volts per division setting, so that's the actual output, and then the yellow one is 10 millivolts per division, which is pretty small. But yeah, when you wave the magnet over, you can not only use the LEDs to tell the polarity, but you can also take a look at the waveform itself. So if you have a north pole, like right now, then you'll have a spike negative first, followed by a positive peak. And then with the south pole, you'll see a positive spike first, and then it'll fall negative. And yeah, that's it. That's the video, and yeah, don't know how to end the video. I still don't know how to not make this awkward. Anyway, thanks for watching, and until next time, I am out. See ya. Oh yeah, and one more thing. You don't actually really need any of these extra wires, so let's just take out the oscilloscope probes since they didn't really work in the first place for some reason. Ooh, I do not like this breadboard at all. Okay, that's out, and then we take the negative terminal for that probe out, and same for this one. And now all we have is the negative voltage, positive voltage, and ground. And if we turn back on the supplies, and then just stick the magnet through the coil of wire, then you get the same thing still. And yeah, I should probably stop doing this.